Can you hear me? Somebody? Saket? No response. Varshini, can you hear me?
Yes, sir.
You can hear. Okay, great. Okay, in the morning session, we started off with the number systems, right? We're discussing numbers. We have seen few properties, right, about numbers. We've seen prime numbers, even odd. We have seen different types of numbers, and we have seen the divisibility test. And we started off with a couple of problems. We solved 4 problems till now. Let's take up the next one. Right? So this is a problem. Try solving this. You can answer in the chat, please, so that others get a chance to solve. Those are joining us from YouTube, please join the Zoom session if you want to discuss the problems.
So should we answer it?
You can put it in the chat, right?
Okay.
Yeah. The question is the difference between the biggest and the smallest 3-digit number. Just you have to find those numbers, right? After that, you will get your answer. Everybody else with the answers. No. Let's see. Ganvi, are you there? Ganavi?
Yes, sir.
Yeah. Did you find the biggest 3-digit number?
The biggest 3-digit number, yes, sir.
Yeah, what is it?
999.
999. Did you read the statement? Each of which has different digits.
Yes, sir. That one I'm searching.
Just think about it. It can't be 999, but what can be the biggest one?
Uh, 9, 8, 987.
Yes, 9, 8, and 7, right? Because it
Yes,
should be
sir.
different, and this is the biggest. So, what is the smallest number then?
102.
102? Yes, all different digits. Yes. So, usually students write 123, correct? Correct. That's when they might go wrong, right? So, 102, what is the difference? Is it 5, 8, and 8? 885. So, many of you probably got A as your answer, right? We're taking 123.
No, sir. The answer is C.
C, right? 885.
Yes. Yes.
So that's what the usual mistake is. We ignore 0 and we go with 123. That's right. Those who have done that mistake would have got the wrong answer. Otherwise, the correct answer is C. Right? Okay. Next question. Try this. Yes.
That is the answer.
So just put in the chat, right? Let others also try to solve. Yes, because options are given, it will become pretty easy, right? Because you can use the options itself. In general, also you can solve. I'm not saying you can't do that, but we'll try the general method. Because I think few of the questions in your NMTC paper will be MCQs, and the rest will be integer type. You have to
Yes.
write down the final answer. So let's assume there are no options given. Right? Not only using options, right? Directly how to solve this problem also. Yes, you didn't figure it out yet. Yes, Roy Saldan.
Yes, sir, to explain.
Yeah, explain.
Okay, sir. So the original number, we'll keep the digit in the tens place as
Okay.
x and the
Okay.
digit in the units place as y.
Tens place is x and units place is y. Fine.
Then, sir, the original number will be 10 times x plus y.
Okay. This is one important method, right? We write this as 10x plus y. If anybody has a doubt why it is, just look at the numbers. So suppose it's 21, right? This is nothing but 20 plus 1, right? Tens digit will be multiplied by 10. I hope you are able to follow, right? That's why we can always write any two-digit number as 10x plus y. So suppose it is a three-digit number, x, y, z. We can write this as 100x plus 10y plus c. It is same as xyz, right? because directly with writing XYZ, we can't calculate the term. Whenever you write it in this form, it's easier to do the calculations or equate it to something, right? That's why we go there. Yes, continue.
Okay, sir. Then the new number,
Yes.
the number in the tens digit will be x plus 5,
Okay.
and the number in the ones digit will be y minus 3.
Y minus 3. Okay.
So then to get the actual number, it will be 10 times x plus 5 whole plus y minus 3.
Plus Y minus 3. Correct.
Then in the statement, it is given that 10 times x plus 5 or the new number is equal to twice the original number.
So the new number, second equation is actually equal to twice the first equation. That's what is given, right?
Yes, sir.
So yeah, okay. So we simply write down the equations and try to solve them. So y minus 3 is equal to twice 10x plus 1. Fine. Okay. Could we solve this? We're going to get 10x plus 50 plus y minus 3 is equal to 20x plus 2y.
Yes.
Right? Well, let me try to simplify. Get x terms to one side, x and y. So this is 47 here. 47 is equal to, what is this?
10x plus y.
10x plus y. Is 10x plus y what we wanted?
Yes, sir. We wanted the original number in
Yeah,
form of
original
10x.
number is 10x plus y itself, right? So you can see that we got option A. So for this problem at least, if the options were given, we obviously can use the options and figure out. See, B and D directly cannot be possible because they told us to add 5 to the tens digit. It's already 7. If I add 5, it's going to cross, it's going to be a 3-digit number, right? I don't know if they have mentioned that it cannot be a 3-digit number. Oh, they have not mentioned, right? So we can always consider again. Okay, let's see. So what will happen is I'll add 5, so this will be 9. I'll subtract 3 here, that will be 4. Yes, 94, this is a twice 47. So directly I got the option A. This is only when options are given, okay. For the other numbers, you can directly figure out. Suppose I'm able to add and make it a 3-digit number. So 70 into whatever the other number is, doesn't matter because this is crossing 140. This is not true. 37, similarly, this is 80. Again, this can maximum at max it can be 80, not something more than that. Similarly, for this number, you can try. You won't get any answer. Right? In case options are given. Otherwise, the traditional method is this. Right? We write down the equations, we solve them. Okay. Next one.
Sir, once can you go to a previous slide?
Yes.
Yes, sir.
Sir, when you subtract two numbers with the same exponent, what happens to the exponent?
Subtracting, there's no law, Orshini. There's no law for subtracting. If you are multiplying, you are dividing, you have. Right. What are the laws we have? We have a power m into a power n, correct? This is what we have, right? We have a power m plus n. Suppose the power is same, so a power m into b power m, we have ab power m, right? But for addition and subtraction, there is no particular law, right? But you can find out without using that. You have to use some properties of numbers, right? Because see, the important question is they have asked you only the units digit, right? The entire number probably was not possible, but for units digit, something can be done. I think those who are in 8th standard would know this. I'll just explain after a couple of minutes. What can be done? How to find the units digit of any number of this sort? We'll have a discussion on that. Okay, we're getting different answers. Okay. Six and four are the popular options right now. Just figure out who is doing the mistake. Okay. Half of you are saying six, half of you are saying four. I'll give you two more minutes, right? You can analyze what the problem says. What can I do about, at least mainly for the students in 7th standard, what can I do about 3 per 2018? Can I find the units digit?
No idea, sir. Yes, you can.
We can. Okay. Yes, Varshini, how did you find out?
No, sir, I did not find out. But I had a doubt if we could subtract directly 5 minus 3 over there and do that into the power of 2000.
No, that certainly is wrong. That you can't do.
Sir,
Yes.
I have a solution. I'm not sure it'll work. I think it'll work. So 3 part 2018.
Yeah.
You can. Okay, we can find a pattern with from the first 3 part 0 ends with 1, 3 ends with 3 part 1 ends with 3, 3 squared ends with 9, 3 cubed ends with 7, and I'm pretty sure it repeats after a while, and we can use that pattern to easily find for 2018. We can do the same for 5 and then subtract both the numbers we got.
Okay, but how are you pretty sure it will repeat?
I have seen such problems before and I remember using this method.
Okay, so you remember the problem, but you don't remember the method. It should be other way around. You should remember the method, you should forget the problem.
Sir, but how exactly are you going to find 3 power 2018 using that pattern? It doesn't
Yeah.
have to do anything with the exponent. It should have some relation with the exponent also.
Let's see if we have a relation.
Sir,
That-
we should divide it by 4 and get some remainder.
Yeah, but why are we doing that, dividing by 4? That is also again what, as Abhish said, that is because some problems that we divide by 4. But why are we doing that? What's so special about 4? It repeats after a cycle of 4, right?
Yes.
If you see, it stopped here. 3 cube is 27. 27. The next number, 3 power 4.
It's 81.
Right?
Yes,
It is
so it's 1.
1.
Okay, so we have to find 3 part 2018 mod 4 and then see which corresponds to it.
Yeah. So what will happen is this number ends with 1, 3, 9 or 7. Then it repeats. How do I know that? What you're doing in 3 power, you're just multiplying with 3, right? Correct?
Yes.
Just imagine, you're 1 if you multiply by 3, you're going to get 3, right? 3 you multiply with 3, you're going to get 9. Now, when you multiply 9 with 3, you're going to get 27. I'm going to ignore the 2. It's not important for units digit, correct?
Yes.
All I'm interested in is in the last digit, correct?
Yes.
Which is 27, so 7. Now 3 into 7 is again 21. Now can you see that once I get this 1, again if I multiply by 3, the pattern will repeat. Is it clear, Varshini?
Yes, sir. So you found out the pattern. Then
Yeah.
how are you going to solve it, sir?
Okay, so you know the pattern, right? For 3 power 0, it is 1, right? For 3 power 1, it is this. 3 power 2, it is this. 3 power 3. Correct. Can you guess what 2018, what it will be?
It'll come under 3 part 2.
3 power 2, right?
Yes.
Exactly. Why? Because when we divide, people were saying divide by 4, correct? So when I divide by 4, what is the remainder is 2. So remainder is 2 in this case, correct?
Yes.
So that's why the answer is 9.
Yes.
Right?
Yes.
Okay, I hope others can follow. If you have a doubt, please ask. Somebody's not, I know 8th standard people are able to follow, but if anybody else.
Could you repeat how you did that?
Okay. just look at this. Did you understand? We are getting only 4 numbers at the units digit at the end: 1, 3, 9, and 7, right? Okay. Now, can you see that when it is 3 power 0, 3 power 0, and 3 power 4, and next 3 power 8 is all ending with 1. Correct? What are these numbers? 0, 4, 8, 12, 16. What are these numbers? Are they multiples of 4?
Yeah.
Not only even number, but they are multiples of 4, correct? Right? Next pattern you see, which are ending with 3. It's 1, it's 5, next number is 9, correct? Then 13, then 17. What are these numbers?
They each adding 4.
Multiple of 4, but one extra more than that, correct?
Yeah.
So in other words, if I divide by 4, what I'm going to get?
What's it?
If I divide by 4, what will be the remainder?
2.
Remainder will be 1.
Yes.
What are the numbers I'm talking about? 1, 5, 9, 13, 17, right? If I divide by 4, the remainder is equal to 1. Okay. What is the next set? Next set is 2, 6, 10, 14, 18, etc. Correct? Here, if I divide by 4, remainder is always 2.
Sir, which one? I couldn't hear you. My internet is a bit low, sir. What did you tell after the 1, 5, 9, 13?
I took another set. 1, 5, this was the set, right? The numbers ending with 3.
Yes.
Right? The next set is numbers ending with 9. So 9 was ending, 3 square was ending with 9, then 3 power 6. Next number would be 3 power 10, then 3 power 14, then 3 power 18, so on. Right?
Yes, sir.
So these are the numbers. So how do I check for these numbers? If I divide by 4, the remainder is 2. Can you see that?
Yes.
So when I divide by 4, if the remainder is 3, the last digit is 7. And if I divide by 4 and the remainder is 0, the last digit is 1. So this is how I figured out what is it for 2018. Okay.
Yes.
This is a specific pattern for 3 power. Right? You can find out any other power you like. You can find 9 power, 7 power. Every unit's digit, you can take one of the digit and find out. Everything has a pattern.
We
That's
can,
why, yeah.
the generalized form is Fermat's little theorem, right?
Formats little thing, yeah, but this is far more basic than that, right?
Yes.
You are using mod there, which is not required here, right? Far more basic than that, right? But first, you should know that there is a pattern, right? Then here we are simply figuring out which number falls under this pattern. So when they give 3 power 2018, I'm just trying to figure out what is the remainder. If the remainder is one among these 4, so based on that, one of them will be my answer. So that's why I said for 8th student, probably you would have seen this and you would have done this, so it will be easy. But for 7, this is the first time. So please try other numbers as well. So see, for 5, it's very easy. Don't you know what is the last digit for 5?
It's 5. Always 5.
Always 5, correct?
Always.
Whatever number power you raise, this unit digit is always 5. And now I've understood that the last digit here is 9, correct?
Yes.
So if I subtract, I have to raise it to the power of, sorry, I will get a carry, right? So 15 minus 9 is 6.
6. Yes.
So your answer is 6. So is the method here?
The same thing, 5 to the power 0, 5 to the power 1.
Yeah, try that, no? 5 power 0 is 5, sorry, is 1.
1.
So that is only one first number you're going to get 1, okay? We'll start from 5 power 1 now. It is 5. Is it okay?
Yes, sir.
Then 5 square is 25, still ending with 5.
Yes, sir.
Then 5 into 5, again, every time I'll get 25 only, right? Obviously, the number will be get bigger. I'm not saying the number. See, this is 25. This is 125. Next is 625. Number is getting bigger, but we don't. We are not interested in the other numbers. We are interested in only the units place. So
Yes.
whenever I multiply by 5, it's going to end in 5 itself. So for all numbers, it's actually 5.
So you're going to divide 2018 by which number, sir?
You need not divide, no? You already know the last digit is 5. Why do you want to divide? Isn't it? See, you
Yes.
divide to find the last digit. But once you know already the last digit is 5, there's no point in finding, right? It doesn't matter which power you raise it to.
Yes, sir. Yes, sir.
Similarly, 6 is such a number, right? 6, if you see the number 6, 6 square is 36. And again, if you multiply this, it is always 6. So even 6 power, whatever power you raise, it's always equal to 6 itself. Last digit is always 6. Similarly, 0 actually. For the other numbers, please try at home, right? Go home after the class or tomorrow maybe. Sit down, check the pattern for 2, 3, 4. 3 we have done, right? 4, 5, 6, 6, all the numbers to check from 1 to 9, right? Each of the numbers will give you a pattern.
Yes.
So that's why I said, see, these things, this comes by practice. Obviously, if you learn like this, somebody teaches you, that's fine. You'll get the answer. Otherwise, there are numbers and the properties of numbers, right? There's no separate chapter for it for you guys. So what they expect is you to know this. So 5 power, this probably everybody would know. It doesn't matter what I raise the power. The last digit is always 5. But for this concept is required, right? Once you know this, I think any problem where they ask you to find the unit digit, you can solve using this. Any problem. Okay. Yes, let's move on. This is a simple one.
Yes.
Sir, it's coming as you can't chat with the CFAL India during this meeting.
Is it?
Sir, you are actually supposed to go to the chat and re-click on your name. Only then we'll get.
Somebody change the host. Just a minute. I'll just.
No, sir. It works for me.
It works for you. Okay. But
Sir,
Yes,
I
sir.
will leave
Re-click
and
on the
join.
name. You have
Sir,
to re-click on the name, sir. Upon your chat box, there's a 2 options. So you have to re-click on CFL India. Only then we'll.
yeah, probably there's multiple CFL India. That's why the confusion is. You would click on CFL India host, right? Probably you could chat there.
Yes, sir.
Yeah.
Yes, sir. I think like it was shifted, like the host
Yeah,
position, so it got
yeah.
changed.
Sir, I will rejoin this meeting, sir.
Okay, try that. If still you have issues, try that. Yeah. Okay. Yes, we're getting answers. But this won't be that difficult for you guys. So somebody's trying to join in that way. Because we know we have already seen the divisibility test for 9. So that would be a great hint.
Now we can send, sir.
Okay, good. Okay, Shashwat, yes, you can answer, I think.
Sir, so first this is the divisibility rule of 9.
Yeah.
So 8 plus 0 plus 3 plus 6 plus 4 plus 2, that is 23. And if we add 4 to 23, it becomes 27, which is a multiple of 9.
Okay. So he says the sum of the digits right now is 23, right? And we know that the number will be divisible by 9 only when the sum of the digits is a multiple of 9, and the closest multiple is 27. So if I add 4, it will be 27, and your answer is 4. So remember one thing, look at the units digit, okay? When you're adding 4, if it is close to 9, your other digits might change. It may not affect your answer, but just cross check once whenever that happens. Okay, this is a simple one. So 4 is your answer. Okay, I think we can skip this one. This is what, twice 1 by 3. I hope everybody knows this, right? So 2 by 3 is nothing but twice of 1 by 3. Let's go here. Question number 10. Okay, getting variety of answers. Let's see. Let's take 2 more minutes. Think about it. Okay. I think we have already seen this, some of the properties here also, right? Of devices and what will happen. You have to use that concept.
Can we assign a value
Could I answer?
to that satisfies? Can I answer, sir?
Can I answer?
Okay, you have a doubt, then ask me a doubt. What's
Yes,
your
sir.
doubt?
Like I assigned A, I kept like A may be 3, and as we know, 3 is a prime number. So 3 has 2 factors, 1 and 3, and so A plus 1 will be 4. That is 3 factors, 1, 2, and 4. So 5 will have 2 factors again, 1 and 5. Sir.
Okay, that's fine. So the question is, that might be, you took an example, that's fine. Are there any other numbers which satisfies the same property? Or
No, sir.
yes, yes, Harsha. Why no?
I have checked other prime numbers and it does not work. I've checked few more.
Yeah, but
Like
how?
I've checked 2, 7. Then I've even checked 5.
Okay,
It
okay,
won't work because anything above 5 will give 4 devices.
okay.
I think it doesn't work because for A plus 1 to have 3 divisors, it should be a perfect square and A should be a prime number.
Yeah.
And only the first thing works. I tried for a lot of square numbers, it doesn't.
Yeah, so same thing everybody is saying. Any logic behind that? So you're just repeating the same thing, right? We are getting for the starting number it worked, and for the later numbers it didn't work. That's the
So you
consensus
told
here.
us we had previous sums where you explained to us that for a number to have exactly 3 divisors, it would be a perfect square.
Yes, that is true. That is true. So a plus 1 has to be a perfect square. I agree. right? And A, based on the information given, is a prime number. My question is, for 3, 4, and 5 it works great, right? 3 and 4, 3 is a prime, 4 is a perfect square, right? Are there any other numbers which satisfies this property? That's all. Are there any other number? Like, let's see, a perfect square like what? 196. So it doesn't make sense, right? Okay. 196 is
No,
too
sir.
easy. Yeah.
But then 195 is not a prime.
Yeah. I'm just giving an example. That's not a prime. That's true. But can't there be a prime, something like that? Right? A perfect square whose one less would be a prime number. Is it possible?
I don't think so because 4 is the next.
Yeah, this is true. I said
Yes.
my next question is, that's all. For this problem it's fine. The next question is there any prime like that? Why not? If not, why not? If
No,
yes, what is it?
because other numbers which go after certain numbers, they'll always have more than like what do you say, like more than 2, sir. I don't think you'll ever get like prime.
But
Prime
see,
number.
there's no proof behind what you're saying, right? It's just an assumption what you're doing, correct?
Yes, sir.
Yeah. So any proof or anything?
There's one thing. Obviously, if A is even.
Yeah.
Oh, okay. I think I got one.
Yeah.
If A plus 1 is odd, it obviously. Wait. Yeah. If A plus 1 is odd, that means the square root of A plus 1 is odd. It means that A is always even, so it cannot be a prime.
Yeah, A plus 1 is odd, certainly fails.
Yeah,
you're right.
so-
Okay.
But what about while A plus 1 is even?
Yeah, that's the question, right? You have to complete it. So you have taken, see, whenever A plus 1 is odd, what will happen is A is even, it won't be a prime. So that fails. Great. So we have removed half of the numbers at least, right? Half of the perfect square, which are even, which are odd, are taken care of. Now our concern is, what happens when A plus 1 is even? Can we find? Can you look at the perfect squares we have? 4, 16. What is the next perfect square? Even perfect square.
Next.
36.
64.
36, no?
6, yes.
Yeah, 36.
Then 64.
Yes.
Okay.
Then
What would be next?
100.
100. Okay.
144.
Next 144,
196.
196.
I think enough. Enough. So whichever is ending with 6, can you remove those also?
Yes.
Yes,
No.
certainly, right?
Oh,
Because,
yes. It does.
yeah, because if it ends with 6, last digit will be 5. I know 5 will be divisible by those numbers.
So if A plus 1 ends with either 4 or 6, it doesn't work.
Yes, if A in even also, if it ends with 4 or 6, why 6? Why 6?
Because 6 6 are 36. It always ends with 6.
Yeah. What about 4? 4 square you mean?
Yeah, 4 squared,
4 square is what?
it's 16.
Yeah, that also ends with 6, right?
Yes.
So you're saying it doesn't work. Okay, it doesn't work. That's what you're saying.
Yeah, any number ending with 4 or 6 doesn't
Okay.
work.
So remaining numbers are what? 2 and 8.
Yes.
Right. What will do about these numbers now?
2, 8, 10 is there.
10 is there, it's fine, right? Always divisible by, sorry. Even 0 is there, yeah. Even 0 is there.
Yeah.
Ending with 2, 8 or 0. Okay, anything specific here? Can we just figure out why? So let's see what will happen. If I subtract 1, it is 63, not a perfect square. If I subtract 100, again 99, not a perfect square. If you subtract this, is 143, not a perfect square.
Yes.
Sorry, not a prime, not a prime.
Square, prime.
Yeah, not a prime.
Yeah, not a prime.
Yeah, but why is it? What if there's a big, very large prime number, right, which we don't know, and if I subtract 1 and it turns out to be sorry, a
If
big
you
perfect
add
square.
one, it's
Yeah.
yeah.
Yeah, how do you prove that? It's not. Okay.
Sir, is there any property like if there's a prime number and then the immediate next number is a square, then the immediate next will be a prime? Is there any such rule?
That's what we are trying to figure out. We are trying to figure out, except this case, if it's a prime, can the next number be a perfect square? Right. That's what we're trying to figure out, right? Okay.
I don't think so.
Yeah. Majority of you don't think, but nobody is giving me a good proof why it is true, right?
Can I have a try, sir?
Yeah, sure.
Yeah. So since like the first few digits which I tried, anything above 5 will give you 4 devices like 8, 6, etc.
Okay. You're talking about which number? A perfect square?
In the sense when you do a plus 1.
Okay. When I do a plus 1.
So a has to be a prime number. So so when you get for example 7, then 5, all of them will have plus 1 will be 8 and 6.
Yeah.
All of them will have four devices. So from that you can say it has to be below 5, and there are only 5.
But you checked only for 2 numbers, right? What about bigger prime numbers? Did you check for all those prime numbers?
No.
Yeah, that is the concern, right? Yeah.
Sure.
Yeah.
Okay, so any number after 4,
Yeah.
6400. Oh, that it has. Oh wait, that doesn't work. Okay, of 2 and 8, everything has more than 3 divisors.
Yeah, but how do you know that? That's the question. Right?
Yeah, that I think might be a little easier to prove.
Yeah, but after that, see, we always take few examples, right? We say it's not working for these 3 numbers, so it won't work for general. If you want to say that it won't work in general, you have to show some property about these 3 numbers, which will continue, right? You can't simply say these 3 numbers. I can't say 64 is not a prime, so all the numbers are not a prime. It doesn't make sense, right?
Yeah.
Right? So we can't take few examples and generalize. Okay. You people can think about it. Right. One more thing. Have you tried? Do you know this? Whenever I take a perfect square,
Yes.
25, 16, so on, they are always in the form of 4k or 4k plus 1.
Yes.
Do you know this?
Euler's division lemma.
Yeah, but why is it? Why is it true? Any idea?
Yes.
Yeah. So I'm just giving you a hint, right? What you can think about for these problems. That's all. So instead of 4k, probably you can think 3k. What happens? So on. Okay. For others who don't know this one, a prime number, right? So, sorry, a perfect square. When you divide by 4, you'll get a remainder of 0 or 1. You'll never get a remainder of 2 and 3. Okay. So this, if you want to prove, simplest proof is you take any even number, right? Any even number is in the form of 2k, right? So if I square this, it's 4k square, correct?
Yes.
Divisible by 4.
Yes.
If I take an odd number and square, 2k plus 1, let me just zoom in so that it's clear here. Right? So 2k plus 1 whole square, this is what? 4k square plus 4k plus 1.
Yes.
Yes. Can you see that this number is divisible by 4, this number is divisible by 4, so remainder is 1.
Yes.
So you take any perfect square as an example, like a random perfect square you pick out, 225. I know it's odd, so remainder is 1. Always 1 when you divide by 4. Okay. If you want, you can practice. This much in details. At 7th, it's not required. I'm just giving few hints. You can try this. You can think of completing this. What you are going to get. Please, you can try. Right. So here you can see this is divisible by 3. This is also divisible by 3. This is also divisible by 3. So all of these are actually in the form of.
No, sir, it's not divisible by 3.
No, it's divisible by 11.
This is not divisible by 3.
11.
Yeah, this is not divisible by 3. So I was looking for a pattern, right? So these two were divisible by 3, right? Here it's not. So check for some couple of numbers to see if you can generalize what you're saying, right? For now, what we have got is the first number and a plus 1, 4, right? So your answer is here 5. It has the number of devices is 2,
Yes.
right? Okay. Try this one. Okay. A lot of you have answered. So, your major types of problems. One is the MCQs, which we've already seen. The second type is this, right? They directly give a dash, right? You have to fill in the number. Okay. So n is a natural number. The square root of the sum of the square of n and 19 is equal to the next natural number, the value of n. Can you write down the equation?
Yes.
Yes. What's the equation?
Root n squared plus 19 is equal to n plus 1.
Root of n square plus 19 is equal to n plus 1. Yes. So you can see that what is given, sum of the square of n and 19. So this is square of 9, and the square root of those numbers is equal to the next number. So it's right.
Yes.
Can't it be n minus 1 also? It depends on what you take, Roy. If you have taken this as n minus 1, this will be n. Okay, that equation is also right. I'm not saying that's wrong. So, but you have to be careful. Here you have to take n minus 1, that's all. It depends on what is your n, that will be your equation. Okay.
No, sir. Like they said, next natural number, sir. So it means always to progress and positive side.
Yeah, yeah. Next is always positive. Yeah.
Okay, sir.
Increment by 1, right? Whenever they say next. Okay. So shall we just square this? If I square, I'm going to get n square plus 19.
Is equal to n squared plus, yeah.
Yeah. This is nothing but n square plus 2n plus 1. The n square term will get cancelled. 2n is equal to 18, or n is 9.
Right. Yes.
Fine.
So can you just wait for a while and copying it down?
Yeah. You want to note down?
Yes, sir. I want to note down.
Yeah.
And sir,
Yes, yes.
are a PDF of these questions available anywhere?
These questions, actually, these are taken from some previous year question papers itself, right?
Yes.
So I think you can find them.
No, yesterday at geometry,
Yesterday we had asked.
we had asked him. He told something, a portal, something will be told about. We'll tell you about it in tomorrow's class.
Where
We'll give
is
it stuff. Yes.
No, actually, I don't know if do you. I think Ignis portal. Did you talk about Ignis portal?
Actually,
No, actually he told he will tell us today.
yes.
Or is
No,
it
actually, the homework problems were there in YouTube, I clicked the link, but then it takes me to register. I don't want to register all again because I already have an account.
I think if you log into your account, Ignis account, right, there are a couple of problems there, right?
Oh.
Sir,
Yeah.
can you tell me how did you remove the square root over there?
I just squared both sides. You know squaring both sides?
Yes, sir.
Yeah, I just squared both sides. So this whole square is nothing but the number itself. Whenever you have root 2 whole square, it's the number itself. Right? So when squaring both sides, one side became n square plus 19 and the other side became n plus 1 whole square.
Yes, sir. And then what did you do for n minus 1 square?
This one, the other side,
Yes, sir.
other side is another equation. We didn't solve that. We solved this side.
Okay, then I understood why I was getting confused.
Yeah, okay. This is because somebody suggested we can take this as n minus 1. Great, not an issue, right? And this is n. But the only problem is they said that the first number is n. So whatever answer you get, you have to write n minus 1, right? So it's better if you use this equation, there won't be any confusion at all.
So how did you write n plus 1 whole square is n square plus 2n plus 1?
The a plus b whole square, a plus b whole square is a square plus b square
Plus
plus
2ab.
plus 2ab, right? That's all.
Oh, okay, sir.
Yeah.
Yes.
Okay.
Yes, sir. I understand. Thank you.
Yes, one more problem.
So does this sum have to do anything with combination and permutation? That's that?
Wait, I have not read the question. Let me also read it.
Yes, sir.
Using
Combination.
It's permutation. 5p2 is 20. That's obviously the answer.
Yeah.
I don't know permutations and combination. I've never learned that. You have to help me out there. Let's see whether we require that concept or not. See, basically, even permutation for lower numbers, permutation or combinations, you always can count, right? I don't think in 7th and 8th they expect you to know permutations and combinations, so don't worry about it too much, right?
Yes, sir. Because we were not taught combination of permutation.
Yeah, so it's not required. You can see it's nothing but counting. For a higher, if the numbers are much, right? You're talking about 10 objects or 10 numbers or 10 elements, then doing permutation combination, you need the formula, right? Otherwise, for smaller numbers, you can even count in a better way, right? This is all about counting, that's all, right? So you count smartly, probably you won't require permutations or combinations. Anyways, let's see. Using only the digits 1, 2, 4, 5, two-digit numbers are formed. The digits of the two-digit number may be same or different. The number of two-digit number is okay. So I have to use
Sir, it is 1, 2, 4, 5, right? Not 1, 2, 3, 4, 5.
No, it's 1, 2, 4, 5 is given, right? So I'm assuming it's 1, 2, 4, 5.
So we are getting as 16. I'm getting a
16. Okay. Many people have answered 20. Are you getting us 20?
Yes, sir.
Yeah, how is it 20?
Just a second. I'll recalculate what I did. I think there's another.
Yeah. Yes, Who else? Even Avi has got
There is
20.
no 3 in that.
Yes, yes.
Consider 3. In that case, it's only 16.
Only 16. Okay, okay, okay.
I think they've forgotten
Four
3.
numbers,
Yeah, they have
sir.
forgotten 3, right? All the
Yes,
options.
sir. I considered 3 and got it as 20. And you get each number has like, if it was only
Each number has 4. So
each
4
number
square
has
16.
4. And 4 goes to 16. Yeah.
Okay. Now, what about 5 numbers? What about 5 numbers? Okay, let's change the
5
question.
into 4. 5 for the 4.
Why 5 into 4? What is that logic there?
No, sir. It will be 5
It's
into
5 into 5. 5
5 into
squared
5.
5.
5 square. 5
25.
square. 5 square.
Okay, 5
5
into
square,
5.
sir.
5 square. Okay.
Yes, sir. Because it can be 3 1, 3 2, 3 4, 3 5, and 3 3.
Okay. So, it's neither permutation
But
nor
then,
combination.
sir, there would be some common elements there.
Okay, what are the common elements?
Like if we take 5 1, 5 2, 5 3, then if we again take from the backwards, sir, like
Okay.
we keep the last digit to be 5, then
Okay.
we get certain amount of common elements.
So, shall we count then?
Sir,
Let us
where
see.
we get common elements? Sir?
Yeah, that's what we are trying to see, right? Let's see. Let's see. Suppose my first digit is 1, right? How many numbers do I have?
Also there, sir.
5.
Three also
5,
there.
sir. 1 1, 1 2, 1 3, 1 2,
Yeah.
1 5.
So it's 1, 2, 3, 4, and 5, right? So there are 5 numbers here, correct?
Yes.
So if there is 2, again 1, 2, 3, 4, 5,
Sir,
correct?
I have a doubt.
Yes.
Is 3 also included?
Yes, 3 is included. Without 3 being included, did you get 20?
Yes. No. I got
No.
16. And you have 4 more cases. 3 1, 3 2, 3 3, 3 4, 3 5.
Yeah, there are more. So for 4 digit, I don't know. Many of you have answered 20. So it's not possible for 4 numbers at least.
I gave it for 5 numbers. Like I first assumed
Okay,
it's
so is it 20 now for 5 numbers?
No, sir. 25.
25, 25. Sir.
It is 25, right? So that's why I said you need not get into permutation, combination, and stuff. Right?
Consider the stuff that it could be repeated. If it can
Yeah,
be repeated,
the
it's 25.
digits, yes, the digits of the 2-digit number may be same or different is given, right? So there's nothing, we are not choosing 2 numbers, right? It can be repeated. So each number has 5 choices. So the answer should be 5 into 5. Somebody had a doubt, there is repetition. So that's why I'm just writing down the examples.
Yes.
There is no possibility of repetition.
Yeah, we can't see any repetitions, right?
Yeah.
No, sir. We can't see.
Each thing has 5 options. So there are 5 things. So it's 25.
Yeah, it's 25. So
Yes.
look, these are the numbers. These are the numbers. There's no repetition. Anybody who had a doubt of repetition, you can ask if there's possible. There's no repetition, right? If you're thinking about interchanging the digits, then probably sometime. But I'm not calculating that way. If you're calculating, choosing 2 numbers and changing them, then probably you think about repetition. That is 1 5 same as 5 1. No, they are different numbers, right? So there's no repetition at all. Correct. So what I do, so I have written down only 50 cases, right? Sorry, 25 cases. Correct. So simple, not that. So no permutation combination is required. Do not worry. Even if they said different numbers, right? Even if they said different numbers, you can always logically write down the same, right? When the number of objects becomes large, right? That's then probably you would require. So they won't give you such problems. Do not worry about it.
If it was 6, it would have been 36. You just have to square the numbers.
In this case, yes. If it is same, because see, there you have 2 numbers you require, right? For a 2-digit number, you require 2 numbers. For the first number, you have 6 choices.
Yes.
Correct. And for the second number, you have 6 choices.
6 choices again.
So
yes.
for each number, if you have 6 choices, the total will be 6 into 6.
Yes.
So that's how you calculate. That's called counting, right? Okay. Fine. Okay.
Can you show the last question?
Yes.
Yes, sir.
have such an irrational number, sir. This number is irrational.
We'll try, just think about it. Well, when discussing, we'll think about how to get it. Right now, just think about it, try to solve. We'll see. Right. Think of, see, whenever huge numbers are given, right? Like for example, 2019th digit is asked. Do you think you are supposed to divide and find out? Just Varshini, do you think they are asking you this problem? No, right? There
No,
would be some
that's my
trick
doubt.
or
How do you find out another
yeah. So
we have
think
to
about
establish
that.
a pattern, sir.
Always there will be a pattern. Whenever such huge numbers are asked, some pattern would be there. The whole trick is finding out what pattern, right? So just figure out. We can spend a couple of minutes on this. So we had, remember, we had discussed the method, right? We had discussed the method of writing a decimal into P by Q, right?
Yeah.
If you had done that, can you see this number? It's a rational number, right?
Yes.
So there might be some repetition. We had seen, right? A recurring decimal we can convert into P by Q form. So it might be one of those.
Oh, yes.
Sir, but P by Q itself is pi by 28. Right?
No, you just divide using your usual method and see if you are getting some pattern.
Like, okay. I got my answer if I actually divide and find the point where it recurs, but even that is a bit long.
Okay. Did you get the point where after how many numbers does it recur?
Yes.
Sir, I
Yeah.
found the decimals like 0.178571428.
So it doesn't recur also.
It does recur. It does recur after. Okay, it doesn't recur normally. Like it'll be something 1. I'm sorry, it'll be 0.1 something. The 1 doesn't recur.
Okay, that's fine. What is the other part? What recurs?
Yeah, that has 7 digits in its recurring part. So we can use, I think, that times method.
You know, just tell me what are the numbers so we can figure out.
Okay.
Sir, 0.178571442.
7, 8,
57142.
42.
7142.
After that it recurs, right?
Yeah.
Yes.
I hope all of you have done by dividing and not using calculators.
Yes, sir.
Right, because calculators won't be allowed in your exam, even though it looks easy to do that way. Anyways, see, whenever it's rational number, there some recurring elements you'll get, because we know if it's non-recurring and all, we can't write it in the form of P by Q, correct? Now we have established a pattern. All you have to figure out what is the 2019th digit. So if I ignore this one, now I'm interested in 2018th digit. Right?
Yes. Yes.
Right? So just figure out. Again, how many numbers are there? 1, 2, 3, 4, 5, 6, 7. So divide by 7.
Yeah, the remainder is 2. So it's
Remainder is 2. This is remainder 1, this is remainder 2. So the answer should be 8.
Yes.
Okay.
But sir, how did you get it again? Like you came to know that those numbers recur when I couldn't hear you.
Okay. These numbers recur, right? This number, how many? A set of 7 numbers. They recur, right?
Yes, sir.
So what will happen? The next number will be 7 here, 8, correct? So if I divide this number 2018 by 7, the remainder I get, right, will be the extra numbers. Can you imagine? I'm just removing all the sets of 7 outside, correct?
Yes, sir.
And what is the remainder now? Remainder is 2. Is correct? So it's 14, it's 61, then 56 or 58. So 58, then 56. Yeah, remainder is 2.
Yes, sir.
Right? If remainder is 2, you can imagine at the end what will happen. So all the sets are gone, and the last 2 elements are 7 and 8. So your last digit should be 8. right? That's what dividing by 7 means, right? That's why we are dividing by 4 there, right? When you divide by 4, all the extra sets are completed. What this pack of 4, right? We have removed them. The last set, what is there? We are interested in the last set. In this case, in the last set, there are only 2 elements. First 2 elements. This is 7 and 8, right? So 8 is your answer. There's one way to.
Some way to find out the remainder without having to divide the whole thing?
In some cases, it's possible for 3 and all, but I don't think dividing should be that difficult, right? See, you have done a difficult task here dividing this to get this number. I know majority of you have used the calculator, but in the exam, this would be a difficult task to get this number, right? Then finding this number shouldn't be a problem. You have to find the remainder by dividing itself, right? Unless you know a factor which is very close to the number already, dividing is the only method. Right? Yes, any more doubts here? Any more doubts?
So why didn't you divide it by 2009, like 2019 by 7?
Because there was one number, digit 1 here, right? Digit 1 was there. So initially, I was finding the 2019th digit, right? Then because this one is not repeating, I just removed this number altogether. Now there 2018th digit is what I'm interested in. That's why I did it. Okay, fine. No more doubts.
Sir.
Yes, yes.
Sir, it does not recur from 7 onwards, sir. 1 and 7 are the beginning, and the bar goes only from number 8 onwards.
Is it? I just believed you people. I thought you people were telling the truth. Can others confirm this is true?
Because in the entire series, 7 doesn't.
Yes,
7 does
sir.
not appear anymore.
Oh,
Yes,
is it?
sir.
Okay. So what is the recurring elements? 5,
by 6.
8, 5, 7, 1, 4, 2. This is the recurring elements?
Yes,
From
sir.
8, yeah.
Okay, okay. Are you sure after this it repeats?
Yes, yes, sir.
Yes, sir.
Okay, okay. Then we have to resolve the problem now. Let's see. Because I have not solved any of these problems, so directly I'm solving in front of you, so I don't know the answers as well. So, okay. So what are we gonna do now? We're gonna take 2019, but we are removing 2 digits here. Okay, so
Yes.
2017. Now divide by 6.
Divided by 6.
Right? Now we are interested in the remainder. So it's 18, 21. 21 remainder is 3, 37, 36. Remainder is 1. So your answer is still 8. You're lucky.
Yes.
Yeah. Remainder is 1. So your answer is still 8.
Yes, sir.
Yeah, okay.
That's
In
fine.
the exam, if you had done this mistake, still you would have got the right answer. Let's move on.
Sir.
Yes.
So for X, are the digits repeating? I mean, like.
Okay, again I have to read the word. X is a 1000-digit number. Y is the sum of its digit. Okay. Z 1000-digit, it should repeat, right? There's no way you can have that without
Oh,
repetition.
yes.
Yeah. If it's greater than 9, there's no chance without repetition. Right? Z is the sum of the digits of Y. W is the sum of digits of Z. Let's see. The maximum possible value of W. Okay.
Sir, I have a doubt, sir. Like I
Yes.
understood till the sum of the digits of y. Like
Okay.
if we take x all as 9, the digits, 1000 digits, so it will become 9000, the sum.
Okay.
And then for y, what should we take it, sir? Like should we keep that 9 or should we replace it by some other number?
See, Y is the sum of the digits. Whatever the sum of those previous digits you got is Y, the new number. Understood?
Yeah.
So, for example, forget about this number. If your number is 323, this is X. Fine. What is Y? Y is 3 plus 3 plus 2.
3 plus 2 plus 3, yeah.
So, which is 8. So, Y is 8.
Yes.
Yes. What is your doubt then?
No, sir. Then for y, the z is the sum of the digits of y. How do we take that then?
Okay. Now, suppose instead of 8, we had got 81. Then Z would be 9. Understood?
Yes, sir. Yes.
See, we got a single digit number. Suppose, obviously, you want it's a 1000-digit number. You won't get a single digit number, right? So you get higher, more digits. So again, take the sum. That will be Z. And for W, again, you have to find the sum of the digits of Z, right? That will give you W, and that's
Okay,
that's what
sir.
you find.
But
Could you
in
please
y,
show how to solve?
Just let him complete. Yes.
sir. But in y, we have all like 9 and the 3 zeros, right, sir? So we'll get a one-digit number itself.
Are you sure it is 9000 though? Are you sure it's 9000?
Yeah, 9000 times. So
9,000 times.
okay,
Just think about it. Think about it.
Yeah.
Okay. Yes. We'll give you, let's say, a couple of minutes at least. Then I think Harsha can answer this. Yes. After 2 minutes, we'll.
Sir, I don't know how to answer. I was just asking.
Yeah, you have a doubt. Okay, then ask. Yeah.
Like in the sense, I don't know how to solve this question. That's why I was just asking.
So just now we discussed, right, with this one who I forgot his name. So we were discussing, right? You got an idea, right? I took a sample number, correct? Correct. And I was trying. So now they are telling you it's a 1000-digit number. So you have to maximize the sum somehow. So how is it possible? Just think. Okay. Let's see. We can take 2 more minutes. Fine. Right. Let's get some ideas.
Sir, the maximum sum should be 9000, I'm sure.
Think about it. Let others also think. See what the question is. They want the maximum possible value of W, right? They didn't tell you anything about X, Y, Z or anything. They want the maximum possible value of W, right? So even your final answer you are getting as 9. Is that what you're getting?
No, sir.
Okay. Just figure. Let others also try.
Sir, but then as we see, it's like taking us quite a lot of time to solve this, like maybe like 14 or 10 questions. It's taking us quite a lot of time. So, and NMTC, I don't know, It's not, I think it's maybe 1 or 2 hours, I'm not sure, sir. But won't it take?
NMTC is for 3 hours, right? I don't exactly remember. I
Is
think
it?
it's for 3 hours.
It's
So
only
1.5 hours.
1.5 hour. Okay, okay. 1.5 hour for 30 questions, right? So per question you get 3 minutes.
30 questions. Okay, sir.
Yeah, yeah.
The first few will be most of the time very easy. It's very
Yeah,
simple.
and I think I think 15 to 20, it's very well said, but 15 to 20 will be MCQs. Rest will be the subjective. So usually the marking scheme is for MCQs, one right, you get 1 mark, and if it's wrong, you get minus half. So it's, if you don't know, please do not attempt. Do not think of attempting at all, right? Because even in higher level competitive exams like JEE, JEE Mains, Advanced, the negative marking is in the ratio of 3:1 or 4:1, something like that. But here the negative marking is in the ratio 1:2. It's very bad. If you're marking, say for example, you marked one correct answer and you marked 2 wrong, you're getting 0, right? So unless you're sure, see, do not worry. You're not gonna solve all the 30 questions. I can guarantee you that, right? So hardly you will be able to understand 25 questions. I'm not talking about the solution. Understand, right? So that is more than enough. Don't take one problem and sit for half an hour. Might be an issue, right? So first figure out the easier problems for you. Then you can go for the difficult ones.
Sir, I heard the first round is online or something. How is that going to be, sir?
I didn't research anything much about NMTC. I don't know this time. This time is different, right? If it's online, the pattern would be similar unless something else is mentioned, right? So the pattern would be
Take it
similar.
over again.
Yes, yes.
After the class, we'll just go and go it.
Yeah. Probably I'll just figure out, and probably in next class I'll just see. Unless they have mentioned something specific, I can't give you new information. But because it's online, I think they will stick with the same pattern, right? It's the same pattern coming on for, I don't know, 5-6 years right now. So
Yes.
I don't know if anything new is mentioned. I'll try to inform you with the same, right?
Sir, I got it, sir. Like it's 89999 because
Now it's figured, right? Yeah. Okay.
yeah.
Yeah, that's
Yes,
the
sir,
whole
but
idea.
still the options don't match, sir.
That
No,
will
sir.
see. That will see. If it's
35.
matching.
We get 35 as the sum.
So 35 is not there in the option. That's what.
Sir, that is Z is
Uh,
35, sir. Then W becomes 8.
Yeah. Yeah. No, W becomes 11.
Yeah, just see. Let's see if others also can figure out. Right. See.
Sir, and they give an option like 22. Will there be answers like 11, sir? I mean, most of the time in the quizzes which I have attempted till now, it's whenever they give a higher question, that itself will be the answer.
No, that they do not use those trick in these exams at least. Okay. See, what quizzes you answer are not that well made at least, right? Like NMTC questions, right? So those are not that difficult as an NMTC question. So that's why I said, please do not attempt unless you're sure. Okay. Even if you're attempting fewer questions, like in 30, if you're only getting 10, more than enough. More than enough. Don't go and mark those answers and get negative marking. Right? It certainly will spoil your score.
Sir, so the topper of NMTC also will not have solved all 30 correctly.
Nobody will solve all 30 questions. Now I don't know that at least for Olympiads, right? After this, in high school, you'll face this PRMO and RMO, all the other Olympiads as well. Correct. So there also, right now, okay, now right now the papers are becoming a bit easier than previously. So before, like when we were writing Olympiads, if you had solved 2 out of 6, also we used to get selected for the RMO level, that is the state level. So it
2
used to
to
be
6, sir?
2 out of 6. Right? It used to be that difficult, right? So just imagine we're sitting for 3 hours and solving only 2 problems, right?
Sir,
Out of
I
6.
think for Z we can use 29, I think.
Huh?
That's a 29, I
Yes,
think.
sir. Z has to be 29.
Yeah, so
That
2
has
plus
to
9, 11.
Oh, is it? Okay, let's see. Okay, let's come back to our problem. Okay, so the question is, we have 1,000 digits, right? 1,000 digits all the way. And the first thing that comes to our mind is we'll take all the digits 9. Okay. If you take all the digits 9, you can see what the problem is. As soon as I take all the digits to be 9, the sum will be 9,000. Right? Because there are 1,000 nines. It will be 9,000. And this is certainly the maximum value sum of x. That's not what is asked. That's why in between specifically I told you that we need the maximum possible value of w. That's asked here. Okay. So for that,
I
what?
got W as
Yes.
sir, like I took X as 89999.
Yeah. So instead of 9,000, you have to take this number 899. Even though this may not be true, but this is a better start than 9,000 at least. Because if I take 9,000, the sum of digits is 9, the rest it is 9 always, right? So W becomes 9 and none of the options is 9. So certainly it's not 9. Okay.
So
What about this?
999 into 9, that's 8991, and add 8 to that.
Okay, what is
We'll get 8999.
Yeah, 8999.
You do 8 plus 9 plus 9 plus 9. So
Yeah,
that
what
is
is
35. That's
Yeah.
35.
35. Why is 35?
5 is 8, which is neither of the options.
Yeah, so again we failed, right?
No,
So
it's W is finally 8. So that's obviously not wrong because I got a million of other numbers which gave me 9.
yeah, we already took 9,000, which was 9, right? So we are not discussing this. Yes, Roy. What is you have got some 11, you're saying, right?
Sir, like rather taking 35, we can take 29, no, sir.
Which one?
W, the sum of digits of W.
Sum of digits of W.
Like the of Z.
And like I took it, I tried
But
it.
29, how are we getting 29? We should see, right? It's fine, absolutely fine to get 29.
Sir, like the sum of digits will be more than 35 anyhow, and it's like less than the maximum possible value also.
Yeah, okay. That makes sense.
Sir, I multiplied 998 into 7. Into 7, and I got some 6986, and to that added 8 and 9, sir, to make the total 1000. So I got 7003, and so that will be value of y. Since that time the value, that will be the value of y. Yes.
Okay. This was not x, right?
Yeah, y, sir.
Okay.
So,
Let me just shift
and
it.
then in that case, we are going to get the value of z as 10, sir. And if we go on shifting that, there's a possibility we can get option A. Because it's 10, right? So option A can be the answer in this kind of a case.
Yeah, let us see. Somebody's claiming to have 11, right? So who's that? Roy?
So me, Sir Smith.
Yeah, Sir Smith, yeah. We'll see whether he can figure out what is it. Okay.
9 is completely possible.
Wait, let Sir Smith answer.
Okay.
Yes. Yeah, okay. Yes.
Sir, yeah, so we want the maximum possible sum of digits, right, sir?
Yeah, okay. This
So
was 35.
obvious, yeah, 35. So yeah, 29 can be a more better answer.
Yes.
As it does not exceed
Less
the
than-
maximum possible value. Also.
Yeah.
I got the answer as 12, sir, by doing something.
How do you get 12?
Like I did 997 into 6, then I added plus 7 plus 8 plus 9. You get the answer as 6006. 6 plus 6, 12.
6,000?
6.
See, whatever you do, you can't cross 35. Do you agree?
Yes, sir.
Like 6006. So 6 plus 6 will be 12, right? We can get option C.
That can't be here, right? We want the sum of digits of W, not Z. You might get 6,600, but you will get 12 here, and W will be 3. Are you following? We want the sum of the digits of W to be maximum, not Z or not Y, right?
Yes.
So that's why I said here. Can you see that the maximum possible value of Z is 35? Yeah, right? Maximum possible is 35. So, but if I take 35, W is 8. Okay. So I don't know what y I'll take, but I can adjust it such that the sum is how much I have to decrease? 6, right? So I'll decrease, sorry, to decrease 6 I have to have 3, right? You can decrease in such a way so that I get this z sum as 11 and the w sum as, sorry, z sum as 29 and the w sum as 11.
Sir,
Yes, sir.
what are the multiplication you got? You did to get that 8993.
This one, let's see. Here,
Yes, sir.
first we had 9,000, all 9s, right? All 9s, right? We reduced one number to 8, correct? To get 8999.
Yes, sir.
Okay. So that number which you reduced to 8, right? I'll reduce it to what? 2? Will I get this sum?
Sir, how many questions are there total today?
This is it. We'll stop. There's no particular limit. I have a lot of questions, but we'll stop where we can, right? Yes.
Sir, actually, 2999999 works the best.
That's what I
You
said.
get
This sum
29.
is that 8 is reduced to 2. That's what I said. 2999. That sum is this. Are you able to follow, Arshini?
Yes, sir.
Understood. Because the same logic I applied here. 19 we reduced to 8, right? To get this sum. Same thing. That 8 I reduced to 2 to get this sum.
Yes, sir. Yes, sir. I got the same thing.
Yeah. Now it's 29. Now it's 11. So your answer is 11.
Yes, sir, but in the exam, like this was a 1,000-digit number, so okay, we could multiply something. If that's something like maybe a huge, like 10 to the power of 100, maybe a huge number or something, then how are we supposed to do it, sir?
See, any problem given, they would give in such a way that you can calculate it easily. So here also, we didn't sit and calculate all the numbers, right? What we did, we saw the value of z, it was 35. We made this maximum. We made it 29 so that I get w maximum, right? We actually didn't check for these numbers at all. These were immaterial for us. I know I can get this sum anyways. I can go backtrack and get this sum. Did I find out 8993 first? No, I didn't do that. What I did is, we maximized this first, then I went back what this should number be, and then I went back and told you what that original number should be. Correct?
Yes, sir.
So however huge the number is, we are gonna do our calculation at the end and then we're gonna backtrack.
No, like it cannot be 12 or 22, sir. Is it because you know that?
Because here, see, we can't cross the maximum value. See, if
Yes,
it can't cross 35, but below 35, I'm certainly sure I can go and get the numbers. Right?
Sir, what is the guarantee that 35 is the largest value?
What is the guarantee this is the largest value?
Yes.
Because I have seen the digits here. Can you tell me any other number here in this 4-digit number which can cross 35? It is 9999, right?
Yeah.
But it
is not
exceeds
possible.
the limit.
Yeah, 9000 is the limit. So I'm not crossing the limit anywhere and getting the maximum value.
Okay.
Yeah. Okay, I think we can stop here. Right? I think
Yes.
it's almost time. So any other doubts you have regarding this problem? So we can sort it.
So what would be next? What topic will be next class?
No, I'll be continuing in number system itself. See, your portions, your majority of your problems will come under number systems. Okay. Like 50%. 50%
if it's number systems, the other 50%, no?
is from geometry, from algebra, a bit of counting. Counting will be there.
Sir, when will be the next class?
Next will be again Saturday, Sundays. So I think similarly, one Saturday, 2 Sunday. I think.
Yes, sir.
Yeah.
Yes, sir. Like the timetable is sent for us.
Yeah. Okay.
Sir, where will we get the previous year question papers and all?
I think you can get it here, or you can find it online. You can get it.
It's not there on the
It's not there, sir. I searched.
Sir, in case you get it, can you please post it in Schoology or in this?
Yeah, sure. I can put that. Right now, I think couple of problems are there on Ignis right now.
No, sir, there are no problems.
Okay, actually, you have seen a GEMS book. Anybody?
Yes,
Which
I have it
is
right now. I
Yeah,
have it.
Yeah, those
I
are
have
the
all
gems.
the NMTC books.
Yeah, so there is a book called under gems. There is a series, right? There is a book for sub-junior itself. There are good problems.
What's gems?
Yeah, it's AMTI books actually. You can find search AMTI. These books are issued by AMTI. It's the Association of Mathematical Teachers, something like that, right? So there are in this there is a particular book for NMTC sub-junior itself. There's sub-junior, there's junior, there's a different book, there's an inter, there's a different book. I'm not saying the problems will come from that, right? But those are good problems there. So that will help you. Yeah, that's the book, yes. So if you can get that, these are not that costly books, so it will help you in your calculations and stuff. Right? So if you want problems for more practice.
Are there answers like how to solve it there?
Yeah, there is there.
These are the sums uploaded.
Which
Like,
one?
where in Ignis are the sums uploaded?
It should be in your home page. I'm not sure.
It's not there.
It's
Like
not
in our
there.
home page, we
It's
have
not there,
question of
sir.
the week, fun with simulations, coding, foundation, and NCRT, and it's in none of.
There's
There's
nothing called
nothing like home page.
NMTC. Okay.
No,
I'll
sir.
do one thing. Tomorrow once I
And
come back to office.
in the YouTube, sir, like one link was sent, but every time I go to that, the homework
I
problem.
think that's not for you. That's for new users, not for CFL students. So what I'll do is tomorrow I'll figure it out. Once I come back to office, right? I'll see whether it's not uploaded for you guys, and I'll add it to your profile, whatever it is, right?
Sir, I had joined the Ignis platform during the MTSC exam. So will I still be able to get the NMTC stuff?
Yeah, you would get it. I'll just make sure tomorrow. Tomorrow I'll make sure that it's put in your profile.
Sir, give me your Telegram link.
A Telegram. I don't post anything on Telegram. I don't.
What's it? Why
Telegram
would
is.
you push anything on telegrams?
No, some people do it. It is a different platform for different things. We are not posting anything on Telegram, so do not worry about it. Okay. So yeah, for Ignis portal, I'll make sure that even in your profiles, I think just we have to add it for your class. That's all. So we'll do that tomorrow, right? We'll get some problems there. And those are really interested in such kind of problems. I think GEMS is a good book, right? At least for starting. Then there are other books for Olympiads we can go through later.
Currently not available via AMTI.
Oh, is it?
No, are available.
Sir, I think we'll get in Z library.
We get it in a PDF, sir. Like I searched AMTI GEMS book, you get a PDF of it.
Okay, I'm not sure whether you'll get that.
I think in
but
LinkedIn
a couple of
it's
books
there.
might be there in the library here. You can use them. But otherwise, it's not. Yeah. Okay, then. Thank you, guys. I think we can end the session here. Right?
Thank you, sir. Bye, sir.
Bye.
Thank you, sir. Bye, sir.
Thank you, sir.
Thank you, sir. Bye, sir.
Sir, the book is there in LibGen, sir.
Okay, I'm not sure. You can just figure out. I don't know how authentic that will be. But yeah, if you can purchase it, well and good. Yes, we can figure out.
LibGen is an open source thingy.
Yeah, but I don't know if you are supposed to sell AMTI, which is a paid version there. So to see that. Anyways, okay, thank you. I'll just end the session.
Thank you, sir. Bye, sir.
Thank you, sir.
Thank you, sir. Bye, sir.